Hi, in this video I want to talk about Java's array list, which is a powerful, predefined, expandable array that should be used a lot. So let's look at it. So we've been talking about generics as a way of making classes and methods work with different types. One place these show up a lot are in classes that hold values in some way, and an array list is an example of a class that does that. It's part of what's called the Java collection framework. And to be honest, you haven't really seen them yet, but you will want to use them a lot in your code. They're nice modern structures. They do a lot for you. They're very safe to use. So I really want you to look at these, hopefully appreciate why they are nicely designed classes, and start getting practice using them. So the array list is a resizable array. A normal Java array, again, is fixed in size. You can put values in there and look at them in an array, but you can't add additional space. So the array list is a resizable array. It has a lot of methods that are built in, allowing you to change values in the array list. And let's just try some code to kind of look at how to use these things. Looks like I lost a parenthesis here at some point. Oops, wait, now I got multiple parentheses. All right, so first let's declare an array list. And it is a generic class, so we have to define the type it's going to hold. In this case, I'm going to have it hold the wrapper class integer. And again, remember, generics in Java can only hold object types, and so there are these wrapper classes to represent primitives, right? So integer is the object equivalent of a primitive. And it's complaining about stuff, and I'm going to, oh, it's not asking me to import it yet. Let's see if I can get it to import for me at some point. So I'm going to call this thing vals. Let's call it vals. And I'm going to make a new empty array list. I am not going to repeat the generic parameter here. I'm just going to use the empty diamond, and I'm going to have an empty constructor that just says make me an empty one of these things. All right, let's try again with a quick fix. All right, import array list. And again, up here, we got array list, and that goes away. Okay, so what can we do with vals once it's an array list? Well, we can add values to it. So add new values. I'm going to say vals.add 5 and vals.add 10. And I'm going to print out what we have here. Again, it's always nice when you're learning a new thing to kind of go through a process of, let's see, what do I want? Vals. Remind myself it's being printed out, right? It's always good to do this sort of iterative thing where you're sort of checking what you're doing as you're going. Okay, so here's vals. It prints out like an array if you use the arrays to string, right? It has square bracket and each element listed one at a time. So what did this do? Every time I said add, it basically expanded the array by 1 and found a space for it and added this to the end. If we don't want to add to the end, there is an overloaded add method. That means, again, it has the same name but different parameters. So vals.add, and I'm gonna let's put in it. The first number is the index, and the second number is what you want to add. And it's a little confusing when they're both like integers, right? If this was an array list of string, it'd be easier to tell which one's the index and which one's not. So if I run this again, I get that 20 inserted at index 0. And notice the other ones are scooted out of the way to make room for it. Now this is not a fully general thing. If I say vals.add at index 20, for example, add 100, and I run it, I get an exception. And again, let's read the exception. It says for index 20, the size of the array was only 3. It had a 5, 10, 20 in it, and it's not allowed. So the index is out of bounds, right? You can only add to an existing spot or at the end. And just to check one thing there, let's see. So if we have 1, 2, 3 things added, so the valid indices are 0, 1, 2, and I'm going to try to add at 3. and I didn't ever print it out, but it didn't crash. Run it again, just to check. Okay, there's the 100. So notice the valid places you can add under this overloaded method are the existing indices 0, 1, 2, plus a new one at the end, 3. I think it's easier if you want to add at the end just to use the one with no index. You don't have to kind of figure it out. All right, so that's pretty nice. We can check the size of this thing, how many elements are in the array. Oops. Int length equals vals dot size. So notice two things about this one. We're a little bit used to like the length method for a string. So this is size instead of length, and also we're used to for a built-in Java array just having the dot length field as opposed to method call. And here it is size method call, right? And if I print out the length, and I could have done this all in one line, right? I could have called the method right here where I'm using this variable. Okay, it's length 4. There's 4 elements with valid indices 0, 1, 2, 3. Let's look at removing values. So if I try vals dot remove 1, what is that going to do? Well, it's a little confusing again if we have both an int. There's only one value, so it has to be an index here, right? It says remove at this index. Oh wait, never mind. I'm sorry. Remove always has one value. There's two forms of it. One that takes an int that is remove it at this index, and one that takes an object of some type, and that says remove if you find a matching value. So if let's print out vals after we're doing a remove 1 and compare. So here we go. 510, 2510, 2510, 100. I said remove at 1, so 0, 1. It removes the 5, and what's left is the 2010, 100, and the length is now 3 as well, right? It actually shrinks that size. If I want to remove a value here, I have to actually remove it as an integer. So it's a little fussy here. Let's say I want to remove the 20 value. I can't say 20. Sorry, 20. If I tried that, again, I'm going to get an index out of bounds because there's no index 20. All right, index 20 out of bounds for length 3. I have to somehow force it to understand that I actually want an integer here. And again, the way to do that is not make a new integer. It's deprecated. It will sort of work, but you don't want to do it. It has this value of 20. And the reason for this is that they're trying to make things a little more performance-oriented with these integers, and so if you do it this way, it kind of stores that 20 object for later use as opposed to making a new integer. I think it's a little awkward myself. And then we should print out the vals afterwards. All this code, but likely can cut and paste most of it, right? So remove the 20, we get the 10 out of 100 left. So anyway, very powerful to add. A typical use is to loop over something like a user input or file, reading from a file, and build up an array list by just adding the new thing at the end one at a time. That keeps the order as well. But it's very, you very often start with an empty array list and then add values as you need them. There's a clear method that just removes everything from it. So if you want to get rid of everything, you don't have to like loop over the indices and remove them. You just say clear. Let's see what else we might want to do. All right, let's loop over these things. So you can treat this sort of like an array. We can have for int index equals 0. Index less than vals dot size. So again, we're just directly asking what the size is in here, and index plus plus, and I'm going to print out just the elements as I see them. You know, we could be doing something else with them, right? Sending to a method or doing something, but vals dot get. We do get already. We could added them and we removed them. We can also just get the value at some index, right? And that throws an out of bounds exception if your index is not valid. So I'm going to run that. So we get what's left in the vals, 10 and 100. We print out the 10 and then print out the 100 based on where they are. There's also a set, right? You can change the value instead of inserting it and expanding it. You just set it and it changes the value where it's already located. You can do a for each loop, which I think again is sort of should be your default in some ways. So for int val in vals, and I'm just going to print out val. I'm going to steal that and print out val. And if I do that, I get the 10 and 100 from the index one, and I get the 10 and 100 from this one. Again, I want you to keep in mind, this is good if you just want to grab the value and do something to it. Put it in some other method call or something like that. This one helps you know where it was. So if you need to go back and change it later, like with a set, that's going to take an index, then you want to use this approach of using the index loop. Also notice if let's do one more little experiment. I'm going to say val plus equals 10. I'm going to add 10 to val each time, and I'm going to print out the array after the fact and see what happens to vals here. I know it's a little hard to keep track of all these different values now. So I printed out, I got a 10, added 10 to it, got the 20, got 100 out of it, added 10 to it, got 110. Here I'm printing out what the array list looks like. It's still 10 and 100, right? I only changed val here. I wasn't changing the internals of vals when I added 10 to val. If I wanted to do something like that, I would have to, again, use an index and set at that spot the new value. And so again, if you're not modifying the array list, you're just pulling values out, the for each loop is really the preferred choice. But if you want to change the internals or do something with that location later, you need the index. Also notice that here I'm pulling out an int val, even though this thing is of integer type. And this works from that sort of automatic unboxing, right? I get a capital I integer out of here one at a time. I can assign it to an int, and it automatically unboxes into the primitive. But you just need to be a little aware of those there's a difference between the int and the integer. And a lot of stuff happens underneath that makes it easy to forget what's actually happening there, but there's some sort of automatic conversion happening that can sometimes cause troubles for you. I can do some searching things. So I can say vals contains, has a nice method contains, decide whether it has that. Contains, whoa, I missed badly there, contains 20, so it doesn't contain 20. Let's see what it says. It's false. Does it contain 10? True. In this case, it's comparing the dot equals of what this turns into, which is the big I integer, with the stored integer, and they see that their internal values are the same. I can also figure out where something is, so I'm going to use the index of 100, for example, and if I run that, it says it's at index 1, right? 0, 1. So it tells you the first instance of the first location it finds that has that value. Again, you could have multiple hundreds in there, right? But this tells you the first one. So there are a few things to be aware of. The array lists are performance-wise a little slower than a primitive array, and some people will seize on that as a reason to keep using primitive arrays. It really depends on your task, but there's this famous quote, we should forget about small efficiencies, say about 90% of the time. Premature optimization is the root of all evil. Now that's a pretty strong statement. What Donald Knuth is saying, who's a very famous computer scientist, he's saying that if you spend all your time trying to do little tiny fussy things, making your code be all weird and hacky to try to get a little more local performance, you're going to miss the point. One, your code is going to be more likely to have bugs in it. It's going to be hard for other people to understand. You might get a little bit of improvement, but really you should be looking at the big picture if you want improvement, right? Figure out where the bottleneck is first, and then work to improve it there. Maybe you should use a different algorithm, for example, binary search instead of sequential search. And then these little tiny little things you're messing with here really don't matter at all compared to the big wins of using the correct algorithm. So again, my general advice is people ask questions about whether this is faster than something else, or for the most part, don't worry about it until it's an actual problem, and two, think about whether, again, you're doing something else that is the real root cause of your inefficiencies. I don't know if I'd go so far to call it evil, but So my recommendation is basically use ArrayList, get used to using it. If it's definitely just some things, it's always be 3 items, maybe a fixed size array is fine. But you may find later that you want to use some of these search things, the contains, index of, and so on, and you can't. You have to convert it to the ArrayList just for that functionality. So ArrayLists have a lot more power than Java arrays, and once you get used to them, you'll love them, and I'd really recommend giving them a try. Thanks.